Okay, today we're going to take a look at the Strand sort challenge presented by Topcoder. Now, Strand sort is a merge sort variant, and the way it sorts an array is it takes an unsorted array, like so, and what it does is in each iteration of the array, it will, here, let's build that one more time. So it takes an array that is unsorted, and it doesn't matter what the sort is, it's going to build up strands of or substrands of this array that with each number that it's comparing against will always grow. Alright, now what this means is, let's say we have the array that I just typed up, 1, 4, 6, 2, 7, 8, 2, 3, 9. Now, as I said, it's going to build up strands, and what it does is it takes that first number, 1, and then it compares it to the next number, which is 4. Now, 4 is greater than 1, so it will build that strand. So that new strand is 1, 4. And then it'll take a look at the next number, and it compares the last number in the current strand with that next number, which is 6. So it pulls that number 6, and then it compares 2. Well, 2 is less than 6, so what it's going to do is move on to the next number, and the next number is 7. So we'll pull the 7 out of that, and then compare 7 to the next number, which is 8. Then it will compare 8 with the next number, which is 2. 2 is less than 8, so it won't pull it. Then the next number, 3, is also less than 8, so it will not pull it. And then the final number is 9, and it will pull that final number. Now the strand that is built then is 1, 4, 6, 7, 8, 9. Now this is a sorted strand from least to greatest, and it is a subarray of the original array. So with that subarray being pulled out, the new original array is going to be 2, 2, and 3. So those are the only numbers that are left in that original array. And then it's going to build another strand out of this smaller subarray, which is, it pulls the first number, and the first number is 2. Then it compares that number with the next number, which is also 2, so it it pulls that one as well. And then the final number is 3, which is greater than 2. So now we have another subarray that is also in order. Finally, what it does is it takes that first strand that was built and it places it in a result array. Now, with that result array being built, we then start merging the new strand, which is 2, 2, 3, into that result array. So it does a binary insertion by pulling off that first number, the lowest digit in that second strand, and it's going to insert that number into this array. So again, with binary insertion, it will split the array in half, and then it will ask if is 2 less than the middle of that array. Well, the middle is 6 or 7, so 2 is less than that. So we'll split that middle in half, and the new middle is 4. Now 2 is less than 4, so it will split the array again. Now that only leaves 1. Now that means that the 2 will then go after the 1, and that new strand will be 1, 2, 4, 6, 7, 8, and 9. Then it does the same thing with the next number, which is 2. Again, it's a binary insertion, so it will add it there. And then finally 3, again, binary insertion, will add it there. So this will create a sorted array by then merging those strands together and then return that final array. So let's go ahead and actually see that happen. So we'll quit out of this terminal, clear the screen, and let's go ahead and run that. Or let's talk about our method. So I wanted to keep the original array as the array that was passed in, and create a temporary array that is basically just a duplicate of the array passed in. Now what this does is it doesn't change that original array at all. So should anything need to be done with that original array, we still have access to it. And I'm using the dupe method for arrays to create a duplicate array. Then I create an empty result array, and this again is just where everything is going when we're done. So what's happening then is I will iterate over the temporary array, and I'm iterating over it until it is empty. Now again, every time we pull out a number to add to a strand, it removes that number from that temporary array. Again, this is another reason why I duplicated the array to start with. So it sets the value that I'm checking with that first value in the temporary array. And that's what I showed you earlier. And then what it's going to do is it's going to use a method for arrays called partition. Now what partition does is it will check a conditional, and if that conditional is true, it will set up all those true values in one partition and all the false into another. So it will ultimately split the array into two separate partitions. One of those partitions is going to be called the sublist. Now this is the substring that we're building up, and the other will be what's left over, and that's going to be what's left of our temp array. And what it's going to do is it's going to basically test whether or not the value is less than or equal to the value of each other unit is less than or equal to the value passed in. If it's less than, if the value is less than that new value, or the value that's being iterated over, VAL, it's going to pass that into the subarray and set value equal to that next, or the end of that sublist. And then it's going to keep testing each of those subsequent vals. Now, we're going to see what happens with each of those sublists as we build them up with this print to screen, which will of course be removed once I submit this method. And then if the result is empty, so if this first this result array is empty, so this is going to be the first iteration of building this first string, or strand I should say. If the result is empty, it's going to add that sublist into result by shifting each of the values into the result array. Remember, these values as they're shifted in will be in sorted order, and yeah, that's pretty much what's going to happen. Now shift, it's going to take in a parameter, and this parameter is just going to be the length of this sublist. So I'm making sure that I'm shifting all of those numbers from that sublist into that result. Now I don't just want to append that sublist, because then it'll just append the entire array as an array into result. So again, this is why I'm using the shift method. Then, or I should say, if the result array is not empty, what's going to happen then is that binary insertion that we talked about a second ago. So that binary insertion is basically going to take two parameters, the result array and the sublist array, and until the sublist is empty, it's going to insert the element, which is basically just that first number in the sublist. It's going to insert it into the result array at the particular element that we search for. And in order to do this, I'm using the built-in binary search at index for Ruby, and it's just going to check and see if, or it's going to set the insert at the point where I, which is each element being passed in, where I is greater than the element. So if the element being passed in is 4, and I have an array of 1, 2, 3, 6, and 7, then my index at 0 is 1, my index at 1 is 2, my index at 2 is 3, and my index at 4 is 6. Now, at index 4, 6 is greater than 4, so that's going to be the insert at point, so that number of that index. And then I use the insert method, which inserts at that index, that insert at index, and it's going to insert the element, which is that first item in the sublist. Once that sublist is empty, it returns the result, which then is what we're dealing with here. And then we continue on building up strands in the temp array until the temp array is empty. Once the temp array is empty and all the numbers have been inserted into the result array, it returns the result. So let's go ahead and see that in action. So we're just going to run the method itself. That's strand sort .rb. And again, remember I put in these print to screen so that we can actually see the result and the sublist being built as it runs through. Okay, so the random array that's passed in, and I passed in 20 numbers between -100 and 100, and we can see that the result at first is an empty array. And so the next thing that it's going to do, it's going to build that sublist. So it takes that 6, and then it compares 6 to 63, says it can't push anything in, compares 6 to 25, pushes it in, then it compares 25 to the next number, which is 68, then it compares 68 to the next number, which is 20, can't push it in, or append, -57, can't append, 8, can't append, 83, it can append, so it does so. And again, for each of these appends, it's actually creating those partitions. So it's removing those values from the temporary array into that sublist partition. Continues all the way, the rest of the array through, and no number is greater than 89. So it takes that sublist, checks to see if result is empty. It is. So it shifts all those numbers in the sublist into the result. Then it starts over. What's left then is that temp array, and it's going to check 63 or -63. Then remember 25 was passed in, 68 was passed in, but 20 wasn't. So it passes in 20 because 20 is greater than -63. Then it's going to test 20 against -57. Nope. 8. Nope. 83 has already been used. 89 has already been used. 17. Nope. 5. Nope. 64. Oh, 64 is greater than 20, so it passes it in. And it's testing 64 against -100. Nope. Against 71. Yes, so it passes it in. And there is no number left that is greater than 71. So now it's going to insert those numbers into the appropriate locations in the result. So notice that 63 goes at the beginning of the result, where it was once 6. Then 20 goes into index 2. 64 goes in index 5, and 71 goes in index 7. Okay, and so it continues all the way through until it builds up the remainder of that result. Notice on the next pass it only finds 5 numbers that fit. Again, there aren't that many numbers left in that original array. I'll actually put in another print to screen to show that original array momentarily. And then we'll just run this again one more time until it builds up all the sublists and finally passes. That final sublist is only one number, which is -12. Inserts -12 where it should go, and then returns the sorted array. So let's go ahead and actually do that real fast. Let's put our print to screen, the temporary array, just so that we can see what's happening to that temporary array each time. That should do it. We'll clear the screen one more time and run that method one more time. So here we see, again, the random actually, let's go ahead and reduce that to 10 numbers so that we can just go through this a little bit faster. So clear the screen, run it one more time. Okay, so now we have 10 numbers. Results array is empty. The temp array is, actually, let's do that one more time. And I know this is kind of tedious, but I want to make sure that we print the temp array before we start pulling numbers out. Okay, so 10 digits, 10 random digits. Temp array is printed, so that's what it was first. Then it builds the partitions. The sublist is that one partition. What's left is the other. Notice it pulls numbers out. The sublist gets, or the temporary array gets shorter by 4 units in this one. Then it pushes that sublist into the results. Then it starts with the next iteration. So the next first in the temporary array is negative 52. 21 is greater than negative 52. 57 is greater than 21. But all the rest of the numbers are still in the temporary array. So that leaves negative 37, 56, and 81 in the temporary array. The result has been amended, and the numbers negative 52, 21, and 57 have been inserted in their appropriate locations. Then taking that next, or that temporary array, it builds the next sublist, negative 37 and 56. Notice that 81 is not pushed in there because negative 81 is less than 56. Builds up that, or what's left is negative 81, builds up the results, inserting each of those numbers in their appropriate locations. Final sublist or strand is negative 81. There are no other numbers in the temporary array. Places negative 81 in the location it's supposed to go, the index it's supposed to go in, and then we have our sorted array. Okay, now one final thing is we have to make sure that it passes all the tests in the RSpec. So let's go ahead and run the RSpec. So that's bundle exec RSpec. And it goes ahead and passes all the tests. So 7 examples were run. It has 0 failures. And of course, it passes all the tests. Again, if there are any questions, please feel free to submit them in the forum, and I will be happy to answer them. Thank you.